Hi, hello. My name is Macy, and this is the work I did with Owen Lockwood, who couldn't be here, at Rensselaer Polytechnic Institute. So we did work on the review of uncertainty in deep reinforcement learning. So in recent years, of course, deep reinforcement learning has been a field that developed a lot and got a lot of astonishing, impressive results. So the story probably starts with AlphaGo, AlphaStar, but later on, like reinforcement learning has been doing really good in Dota, in StarCraft. However, the reinforcement learning is not, it has been incorporated a lot, but there's still like issues with it for using it. All of the games were on day to day. Part of the issue we believe is the uncertainty issue that is incorporated in in the learning process that hasn't been dealt well. So just a little bit review of the concept in reinforcement learning. Basically, there's an environment and there's an agent does the action and then receive reward from the environment and also observe state from the environment. And when you do your learning process, there are basically two different ways to go. One is value-based, to somehow estimate a Q value for being in a particular state and execute a particular action. You can either do this using a table-based method or use a neural network to estimate these Q values. Alternatively, you could do something called actor-critic. So this one basically just combines both a value estimation and also a policy estimation. The policy in this case is just like, what should I do given the current state? Can I directly map the state to the action? So the actor-critic, you probably have heard about PPO, which is this algorithm that played Dota and all of this. So this one is actually actor-critic. So they have both networks, and then these two work with each other. So typically, the work on on the uncertainty in deep reinforcement learning are done on the value-based network. So either on this value-based method directly, such as DQN, DDQN, and such, or if the algorithm itself is actor-critic, it will be done on the value function, which is basically just the estimation of those Q values. We do have a discussion on why that is the case in the poster. So when talking about uncertainties, just like generally as a concept, there are two types of those. One is aleatoric, which is basically the uncertainty that exists in the data. So if your data looks like this, so the data itself can be non-deterministic, just like no matter what you do, there are variabilities in your data. So this type of uncertainty in general, people believe it cannot be reduced by training your model, no matter how you train it. The other type is called epistematic uncertainty. So this one is something that is introduced in your training process that you're not able to deal with, and you can improve over time by having more data, build a better model, or tune your parameters in a different way. So in terms of reinforcement learning, like where uncertainty are generated, of course, there are environmental uncertainty, but there are also a lot of uncertainty resulted from the exploration process. So basically, most of the algorithm works very well when the reward is dense. The reward is dense basically means you're going to encounter some reward or punishment from the environment all the time. Then even the random exploration sequence is going to work pretty well. But if your reward is sparse, that means you wait a lot for this reward signal. Then how do you explore becomes a problem by itself. And this noisy exploration behavior itself would introduce uncertainty in the models. Your model is just unsure about what should I do in the state. Of course, being a machine learning algorithm will give you answer regardless. Though in those cases, we would say the model is unsure about what it should do. So in terms of reducing uncertainty, a lot of algorithms are stepping from the idea of let's try to explore the environment better. So if you think about your state space as a checkboard, some of the algorithm would say this count-based. They would say, let's just try to explore each of the state with sufficient amount of visit. Alternatively, people have said, okay, let's try to do prediction-based. That's a little bit fancier. So let's use a neural network to predict what my current neural network's prediction on each of the states and see the easier it is to predict, then I think my uncertainty is lower. It's the harder it is to predict, it's higher. So we do have more details in the slides, but then the two other major approach that many people have practiced are Monte Carlo dropout, which is very similar to what you do if you train other deep learning models, and then bootstraps on data. So I'll just stop here. This is a review paper. We have a poster this afternoon. We reviewed many techniques that people applied with their results. So I'll end here.